Okay, everybody, so yesterday on the board, we were trying to introduce how to factor trinomials, and you guys were doing a pretty good job, so we're going to officially start the rest of this week just factoring our faces off. So, factoring quadratic trinomial notes. So there are several ways that we can factor a polynomial of the form ax squared plus bx plus c. So a is not going to be 0, because if a was 0, then it would not be a quadratic trinomial. It would just be a binomial that would not factor, or it would just have a GCF to pull out. So I'm going to show you several different ways you could do it. You figure out which way you like to do it. There's not really one correct way to factor. There's going to be, some ways that you'll see me always do it, but again, I've been doing this for 30 years, so whatever. I'm not that old. Method 1, called reverse foiling. Okay, now FOIL is a fancy word for multiplying binomials together. We call it distributing. It's the same thing. So we are going to mentally work backwards from multiplying. So this works best for the simple case when a equals 1, when we just have an x squared out in front. It says it's a lot harder when a equals what does not equal 1, but nothing's hard about this. So a lot harder is a kind of a wrong thing to say. So the first thing we would do is list the factors of c. All right, c is the n term, the constant. So the factors of c, like if the number was 12, we would list numbers like 1, 2, 3, 4, 6, and 12, all the numbers that go into 12. If the sign of c is positive, then the signs of the binomial are the same. So if they're going to multiply to a positive at the end, then the binomial signs, the two symbols in the middle, are going to be both negative or they're going to be both positive. But if they sum up to a negative, they'll be both negative. If they sum up to a positive, then they'll be both positive. So we want the factors that add up to that middle term. So yesterday when I was saying, hey, give me two numbers that multiply to this and add to that, this is what we were doing. So if the sign of c is negative, that means one of the binomials is going to have a minus and the other one's going to have a plus. And we got to make sure that when we add the two numbers that we're finding, just like we were doing on the board yesterday, that they do add to that middle term b. So this first example here, we're going to factor x squared plus 5x plus 6. So step 1, we list the factors of 6. So numbers that go into 6 are 1, 2, 3, and 6. Step 2, the value of c, 6 is positive. Okay? So which factors of 6 add up to 5? All right, so 1 and 6 don't add up to 5. 2 and 3 do. So 2 and 3 would be the factors that I'm looking for. The signs of the factors will be positive because b is positive. So that it's got to add up to a positive 5, so everything's going to add and be positive. So this 2 and that 3 are going to be represented in factored form like that, where you have the positive 2 and the positive 3. That's factoring. If we multiply that out, you get x squared plus 5x plus 6. So you always know if you're going to be right or wrong with factoring, because if you just multiply your answer, you better get the original. And if you don't, you're wrong. So then you pull out your red pen and mark it wrong. Example 2. So same numbers, different signs. It's going to change how we do things. So again, we list the factors of 6, 1, 2, 3, and 6. The value of c is negative, so that means the numbers that we pick, one's going to be positive and one's going to be negative. And when we add the two numbers together, we have to get a negative 5. So what two numbers will you add together to multiply to a negative 6 and add to a negative 5? So that's going to be using the negative 6 and a positive 1. Okay, So those are going to be my two numbers, and these two numbers are going to how we represent the factored version. X minus 6 for the negative 6, and x plus 1 for the positive 1. It is that easy. So let's try a couple here. Why don't you pause the video and try A, B, and C, and then when everyone's done, turn it back on. And before you try it, there is a change we have to make. This negative 10 right there, can you guys make that negative 11x? That would be better. Okay? So now pause it and we'll check the answers. Okay. So on A, the factors of 12 would be 1, 2, 3, 4, 6, and 12. And, you know, that they multiply to 12, so you got to pair up the ones that multiply to 12. And which of those multiply to 12 and add to 8? 2 and 6. So you should have got x plus 2, x plus 6. Letter B, the numbers that multiply to 10 would be 1 and 10, 2 and 5. But we need it multiplying to a positive 10 and adding up to a negative. That means they're both going to be negative. So everything gets a negative attached to it. And the two numbers that add up to a negative 11 would be the negative 1 and the negative 10. So you should have got x minus 1, x minus 10. C, the numbers that multiply to a negative 8. 1 and 8 go into that. 2 and 4 go into that. So that's it. So these are what go together. And if it multiplies to a negative, that means that you got to look at how far the numbers are apart, basically. So which of the pairs are 2 apart? It would be 2 and 4, and since you add up to the negative, that means the 4 has to be a negative. So this will factor to x minus 4, x plus 2. Okay. So that's just the way that you could do this by knowing what we were doing on the board yesterday. What multiplies to the end adds to the middle. Put those numbers in the parentheses. The second method here is called the box method. Just another way to organize your work here. So this method works for any value of A. So what we do is we draw a 2 by 2 box, like we have below. We put the ax squared in the upper left box and c in the lower right box. So I'm going to look at this first example while we read the 4 bullet points. So ax squared with this the 2x squared here would go in the upper left box. The c, which is negative 3, goes in the lower right box. We're going to multiply the a times the c. So a times c in this case would be 2 times negative 3, which gives negative 6. So based on the signs of the trinomial, we can determine whether we want factors that add up or subtract to c. All right, so same thing as method 1. So we're going to place the factors that multiply to the negative 6 and add to that negative 5 in the other boxes. Okay, so we're placing the factors as coefficients to the x variable in the remaining boxes. So we have to have this. We have to add this up to negative 5x to get that negative using factors of negative 6. So we could put negative 6x and a positive 1x. Those would multiply to a negative 6, the coefficients, and add up to the negative 5. It did not matter where I put those two. I could have put them anywhere I wanted. Then the last thing you do is extract the common factors vertically and horizontally. Okay? And those are going to be your binomials. Okay? So the common factor vertically in that first column is going to be an x. the common factor in the second column going down is going to be a negative 3. Okay. The common factor, so I just did that going down that way and going down that way. Pulled out the greatest common factor. Now going to the right, going this way, the common factor of 2x squared minus 6x would be 2x. And the common factor of that horizontal would be 1, because there isn't a common factor between 1x and 3. So what that ends up being, I look at that, and that, it becomes 2x and a positive 1 and an x minus 3. And that's factored. So it's a way to organize your work. The method, what you're doing is really the same as what you're always going to do when you factor. It's just a way to organize. So let's do this other one here. And before we do it, again, there's a typo here. This negative 7x should be minus 11x. Okay. So either pause the video and try it on your own, or watch me do it. So I'm going to put the 2x squared and the 12 down here. I multiply 2 times 12. That gives me 24. So I need two numbers that multiply to a positive 24 and add up to a negative 11. You should have found that that's negative 8x and negative 3x, because negative 8 times negative 3 is positive 24, and when you add them, you get negative 11. The greatest common factor down the first column would be x. The greatest common factor down the second column would be, and I'm always going to pull out, if my leading degree is negative, I'm going to pull out that negative. So here I'm going to pull out the negative 4, would be the GCF there. Going to the right, first row, the greatest common factor would be 2x. And the greatest common factor in the second row, again, my leading degree term is negative, so that means I'm going to pull out a negative 3. Okay. I didn't pull out a negative in that first row because the 2x squared was positive. You want to look at the first term. If it's negative, pull out a negative. So that's going to give you the factors x minus 4, 2x minus 3. And it's factored. Okay. The third method is kind of similar to the box method, but there's some other computation that you have to do. All right, so this is called the diamond method. Okay. Again, we're doing the same thing in every problem, but it's just a different way to organize your work. All right, you're going to decide which one you want. That's your homework assignment, to be like, I think I'm going to do diamond method all the time. Okay, but before you do diamond method, you got to hold up the diamond symbol with your two hands. If you liked WCW wrestling back in the 90s, there's a guy named Diamond Dallas Page that held up the diamond sign. He must have been a diamond method guy when he foiled in high school, or factored in high school. That's why I liked him. All right, so this method works for any value of A. Steps: in the top, put the product of A and C. So let's look while we're reading this at this one right here. So we put the negative 6, that's at the top, product of A and C. In the bottom, you put the value of B, which was your negative 5. Okay, so we go with the first, multiply, and then the value of B. The left and the right locations are the numbers that when multiplied give us A, C, and add us to give us B. So that's the same thing we were looking at in the last problem when we're trying to, when we're looking at factors that add to that middle term. So that's step 2 right here, where the numbers that multiply to negative 6 and add to a negative 5 are negative 6 and 1. Now, you take the two numbers in the the columns we just filled in step 2, and we write fractions with those with the leading coefficient 2x. So that's the right here. Right here, we get that 2x from this, whatever that coefficient is. Okay, so that -6 and the 1 now become denominators. Then we simplify the fractions. 2x over -6 is x over -3, and 2x over 1 is 2x over 1. And look how that turns into the factors. So x minus 3, 2x plus 1. So that's this diamond method. All right. So let's try this one quick. I'm going to put, remember, top part, you do your AC, which is -12. Then on the bottom, you put the middle, which is -1. So we're looking for two numbers that multiply to a -12 and add to a -1, which, if I remember, would be -4 and a +3. Then we put the 6x on the top of both of those, and then we reduce those fractions. So 6x over -4 would be 3x over a -2, and 6x over 3 would be 2x over 1. So that becomes 3x minus 2 and 2x plus 1. And that's it. That's how you factor one of those using the old diamond cutter. Let's call it the diamond cutter method. All right, and then there's a fourth method that you could possibly use called slide and divide. And this one's cool because it rhymes. All right, so what we're going to do is slide the leading coefficient to the end and multiply it by c. So looking at this example right here, slide that 3, the leading coefficient, to the end by multiplying it by -10, so you now have -30 on the end. Middle term doesn't change. We factor it normally. What multiplies to -30 adds to 1, so that's going to be a +6 and a -5. Now after we do that, we divide those numbers on the end by that a term. So both get divided by a, so 6 over 3 and -5 over 3. And then we simplify those fractions. 6 over 3 gives you the 2. 5 over 3 doesn't give you anything, it's just 5 over 3. And since we have a fraction that's left over, we move that denominator in front of the x in that parenthesis. So that 3 would go right there, and that is it factored. Slide and divide. Doesn't get much better than that. So let's try a slide and divide. Okay. So the first step, I'm going to rewrite this as x squared minus 7x plus 10. What two numbers multiply to 10 and add up to a -7? -5 and -2. And now I divide by that first number, simplify the fractions, so that's 5/2 and x minus 1, and then I slide the 2 back. 2x minus 5, x minus 1. Slide and divide. Okay. All right. So now we have some practice to do. Trying to load the screen here. I believe there's just 10, yes. Okay, so we got 10 to practice here. Your job is to use any method you want, but try a couple. Just, don't, decide right away. Decide which one you like to do. I really believe that the first 4 should only be used with method 1 because you got a leading coefficient that's a 1. I mean, these are the easy ones. So, number 1, what 2 numbers multiply to 5 and add to 6? 5 and 1, factored. Number 2, what 2 numbers multiply to a negative 12 and add up to a negative 4? Well, that's going to be negative 6 and 2. So that becomes x minus 6, x plus 2. Number 3, numbers that multiply to a negative 12 that are 1 number apart and add up to a negative. That's negative 4 and 3. So x minus 4, x plus 3. What numbers multiply to a 14 and add to a 9? Pretty sure that's 7 and 2. X plus 7, x plus 2. So all those should be method 1 without question. So now the other ones here, 5, 6, 7, 8, 9, and well, maybe not 10 yet. We'll talk 10 in a second. But these, 6 doesn't either. So let's talk 5. 5, let's use the box method on 5. So I put the 2w squared up there. I put the 3 down here. And then I go, what numbers multiply to 6 and add up to 7? Pretty sure that's 6 and 1. So I put a 6w and a 1w in my other ones. Remember, it doesn't matter which box you put those in. You could reverse them, whatever. And then I factor out some GCF. So at the first column, it's w. Second column, it's 3. First row, 2w. Second row, 1. So that becomes w plus 3, 2w plus 1. Number 6, again, leading coefficient 1. What 2 numbers multiply to a negative 24 that are 2 apart and have to add up to a positive 6, negative 4. Number 7. Notice on number 7 that these have a GCF in there. So the first thing I'm going to do on 7 is pull out a 4. That's going to be the first step all the time, is we look for a GCF to pull out to make the numbers easier. So now it's that, which is the same thing as 4 multiplied by x squared plus 0x minus 1. So I just need 2 numbers that multiply to a negative 1 and add up to 0. I'm pretty sure that's 1 and negative 1. So this would be a 4 on the outside with multiplying conjugates. And you guys know that conjugates would give you those difference of 2 perfect squares. We could have got that right away after pulling that 4 out. Number 8. Let's do the diamond cutter. So I multiply my n terms. 5a squared times negative 4 would be negative 20a squared. Well, I don't have to put the a squared, just the negative 20. And then below it, I put the middle term, negative 8. So I'm looking for 2 numbers that multiply to a negative 20 and add to a negative 8. Let's see, negative 20. With 20s, we got 1 and 20. Nope. We got 2 and 10. Yep. So let's put our negative 10 and our positive 2 right there. And then we take our original leading coefficient, which would be 5a, and we put that over both of those, and then we reduce those fractions. So that would be a over a negative 2, and 5a over 2, which doesn't reduce. So that factors to a minus 2, 5a plus 2. And that's the diamond method. 9 and 10. Let's, on number 9, do some slide and divide. So the first step is to rewrite this as n squared plus 13n plus 12. Okay. And then after we do that, we factor normally what multiplies to 12 and add to 13. That would be n plus 12, n plus 1. And then you take the original leading coefficient and put it underneath both of those. Simplify those fractions, so that's going to be n plus 4 and n plus 1/3, which then becomes n plus 4, 3n plus 1. Okay. Number 10 has a leading coefficient that is negative, and that's a problem. We don't like that. So what we're going to always do, if that's the case, is factor out that negative 1 and change the signs inside. And then I'm just going to factor that inside. Leave that negative outside. Okay. So this is just a basic one. What multiplies to a negative 5 and adds to a 4, that would be positive 5 and a negative 1. So it would be x plus 5, x minus 1. Keep that negative on the outside, and it is factored. Okay. Okay, so if you can go to the think about a plan, we're going to do that one together, and then you'll have time to use the practice to factor and get really good at the basic factoring, and tomorrow we're just going to factor more using all the methods and just, again, factor, factor, factor. All right? So go to the okay. So recreation. A rectangular skateboard park has an area of x squared plus 15x plus 54. What are the possible dimensions of the park? Use factoring. Okay, so the area of the skateboard park. It's a rectangular skateboard park, and they're telling us what the area is. So that's going to be x squared plus 15x plus 54. Okay. So the dimensions of a normal rectangle are its length and its width. Okay. The blank of the area polynomial are possible dimensions of the skateboard park. Okay. So what we want to put in there is the word factors. The factors of the area polynomial. So what we need is to find the factors of the area polynomial. So we're going to complete this table and list the factors of that rectangle. So all the factors of 54, zoom in there, factors of 54. So 1 and 54 is an option, and if we add up those factors, I get 55. 2 and 27 would be factors of 54, and those add up to 29. 3 and 18 are factors of 54, and those add up to 21. 4 doesn't go into 54, 5 doesn't go into 54, 6 does. So 6 and 9 are factors of 54, and those add up to 15. 7 doesn't, 8 doesn't, 9 doesn't. As soon as we get to one that we already used, we're done listing all the factors. If we go back to what this has to add up to in the area polynomial, what is it? You're right, 15. So we write the factored polynomial would have to go along the lines of this row. So the factored polynomial would be x plus 6, x plus 9. So what it wants are the possible dimensions of the skateboard park. So the rectangular skateboard park, you're going to have one side that's x plus 6 and one side that's going to be x plus 9. No matter what we put in for x, the sides of the rectangle are always going to be how far apart? Yes, 3 apart, because one you're adding 6, the other you're adding 9. So possible dimensions for this park, if x was 0, which it very well could be, x could be 0, would be a 6 by 9 park. That's pretty small. But it could also be 7 by 10. It can also be 8 by 11. So basically we're looking at all rectangles, an infinite amount of rectangles, because they don't really constrain the fact of how big this could possibly be, that the sides are going to be 3 apart. Because based on the area formula, the area polynomial, when we factor it, the factors are 3 apart, therefore the dimensions have to be 3 apart. So if the factors are 3 apart, then the dimensions are 3 apart. And factoring is what we're able to do to figure that cool stuff out. So I want you to go to the practice for this section 8.5. The answers are up on the table up front. They're attached to the seating chart. Check them. If you're confused on any, get really good at it. And then you can do your Math Excel assignment for section 8.5 and get that done today in class. Tomorrow we will factor, and factor some more Thursday. And of course we have to factor on Friday. Okay, all Fridays are now going to be called Factor Friday. So have a good rest of your day. Hope you enjoyed the video.